Ladies and gentlemen.
Welcome to the BlockCrunch podcast, the go-to podcast for investors and builders in crypto. And before we get started, just a reminder for you guys out there, the BlockCrunch podcast is intended for informational purposes only. Neither the host nor its guests are licensed financial advisors, and nothing discussed should be construed as financial advice. Views held by BlockCrunch's guests are their own, and sponsorship messages do not constitute financial advice or endorsement. With that out of the way, let's jump right in. Today's episode of the BlockCrunch podcast is brought to you by Protocol Labs, the guys behind Filecoin. And with me today is Colin Efren, who leads ecosystem at Protocol Labs. So Colin, can you give us a brief state of the Filecoin ecosystem today?
So Filecoin is almost 15 exabytes of storage capacity and 463 petabytes of real storage data. And if you take all of Web3 storage protocols, Filecoin powers 99% of total storage capacity and 95% of storage utilization. In 2002, 70,000 developers were exposed to Filecoin through our various hackathon partnerships, and 500 startups are actively building on Filecoin, ranging from Series Seed funding to Series D funding. In aggregate, they've raised about $500 million in capital and continue to grow into 2023.
Hello there. Now, before I move on, I'd love to thank the hundreds of you who have subscribed to BlockCrunch VIP, because with your support, I've been able to share my real thoughts on specific projects that I don't usually share on interviews in a format that I enjoy more, which is bi-weekly written posts. We've also been able to offer exclusive AMAs, sharing my investment frameworks, interactable models, and breaking down important trends before they become big. Now, we even had Elon Musk comment on one of our threads recently. So if you haven't already, head on over to theblockcrunch.com/VIP and you can access dozens of hours of research for what you'd spend on a coffee a day. Hey everybody, welcome back to another episode of the BlockCrunch podcast. Now, as you know, one ecosystem that we've been spending a lot of time on is Filecoin. And this week, they just announced that their FVM is launching, which effectively transitions Filecoin into a full-fledged L1 instead of just a storage network that it was known for. So now it's increasingly important for me as an investor to understand just how important Filecoin will be and how it affects the broader L1 and DApp landscape. And as part of this sponsored series by Protocol Labs, I'm really excited to dive into another project in the ecosystem, which is Web3Storage. Now, Web3Storage is not just an idea. In fact, it's a project that's already helped store more than 66,000 gigabytes worth of data on IPFS, and it's becoming an increasingly essential layer for everything ranging from NFT projects to your general online storage user. So to understand Filecoin, storage in crypto, and what it means for your favorite projects, it's essential to understand what Web3Storage is and how it works. So I'm really excited to bring on David from Web3Storage on the show today to talk to us everything storage. So welcome, David.
Hey, thanks for having me.
Yeah, so just to get us started, now, not many people are familiar with how storage actually works online. It's a very complicated process. There are many layers involved. So can you explain to us, as if we're 5 years old, just what is happening when we store and retrieve a file online?
Yeah, I guess there's like a Web3 version of it, and then there's the one specific to Filecoin, and there's the more general version, which would be most helpful.
I think why don't we start with the Web2 version, and then maybe what differs in the Web3 version?
Yeah, so when you store a file on a computer, it's stored on some sort of hard drive somewhere. The zeros and ones are accessible, let's say locally. So you don't need to be connected on the network to fetch your data. But with the power of the internet and the protocols that we're used to using in the Web2 world, you can store data somewhere else by sending those bits to a remote server. That remote server has a usually HTTP URL associated with it that corresponds to the exact location of that server on the web. And if you have the permissions to, you can also download that data back if you need to. So basically, the HTTP URL corresponds to a IP address and a location on the server corresponding to that IP address. You pull down the download and you get it back. So you need that connectivity. You need to be able to talk to the systems that can locate exactly the location of that download. From there, depending on your connection, you can get it back pretty quickly, pretty slowly, etc.
And in the Web3 version, what is different? Is it kind of similar things happening, but instead of a centralized device, you have, a decentralized network?
Yeah, so it is useful. I'll use IPFS and Filecoin as the example here. Different solutions might have slightly different takes on it, but I think it separates the layers of what's going on pretty well if you split up the IPFS Filecoin pieces. So with the IPFS side of things, instead of referencing data by the location of it on the web, you start to reference data via a hash of the data itself. So you have something that corresponds mathematically to the data that you're trying to fetch. That hash, that location, or the content address, it's called in the IPFS world, that can't correspond to any other piece of data. It's completely unique. So what you basically do is broadcast to the rest of the network, hey, I'm looking for this exact piece of data, and anyone out there who has that data and is willing to serve it can send it over to you. So rather than being bottlenecked on a specific location somewhere, maybe there's 5 copies of the data out there available on the web that you want. You can only get it from the one place that you know the location of in the Web 2 world, or you can get it from any of the 5 in the Web 3 world. And it's great because now you have more resiliency. There's less of a single point of failure with really sophisticated systems, very similar to how BitTorrent works. You can download from multiple peers at once. So you can see video streaming use cases be a lot faster, that sort of thing. So IPFS is really powerful there. It doesn't make statements about where the data is physically stored. It just makes statements about how you get the data back, how you reference that data. The physical storage piece is slightly different, where you can kind of decentralize down all the way to the actual hardware itself. So I'll compare Filecoin versus someone like AWS, where AWS is a single cloud storage provider who has a bunch of servers in a bunch of data centers, and basically they abstract those servers from your perspective via a single HTTP URL. But if the AWS region where your data sits goes down, you can't get it back out anymore. But AWS, to kind of incentivize you to sticking around with them and store as much data with you as possible, they can do things like give you really good deals for storing more and more data with them. They actually provide a really valuable service, which is economically like a great business model where they run a lot of hardware at scale, way cheaper than it would be for you to run it yourself. And then they'll charge you some price that's above their kind of unit cost for that storage, but below the cost out of pocket for you to kind of run a smaller operation yourself, pay SREs and engineers to keep things up, that sort of thing. But they are also super incentivized to do things like lock you in. So you can totally see this with AWS's pricing scheme, for instance. And I'm throwing shade at AWS right now. And again, I'll emphasize I'm someone who finds their service really valuable and stuff. But economics do what they do, and their pricing structure is such that storing data is relatively cheap, more expensive actually nowadays. But the cost of getting data out, the egress cost, is really, really expensive. So they kind of keep you locked in from that sense. And, they have solutions like CDNs for kind of ongoing traffic, but one-time migrations sometimes cost prohibitive for people who end up regretting all the startup credits that they got from AWS from the early days.
Yeah, no, so it sounds like it's Hotel California. Basically, it's very easy to check in, but once you're in, they charge you a lot to get your data out. But at the same time, I think some of the points you mentioned, like resiliency and lack of a central point of failure for Web3 storage, are those? Have you seen that? Are they important enough value propositions for users? Because for me, as a Google Drive user, for instance, I haven't really faced any type of failures with Google servers.
Yeah, and I mean, it's a really good point. These folks do a really good job with keeping things up. I would generally say that single points of failure are maybe a second order need we found with our users. First order needs are more around cost and performance and that sort of thing. But it's not something that really burns you until you feel it yourself. And there's actually, if you just go through Twitter's history, for instance, lots of incidents where an entire region of a cloud provider will go down, and all of a sudden you can't use Slack anymore. You can't use all your favorite apps, and it depending on this is why like hospitals and finance companies who do trading and things like that, they have their own systems because they can't afford even a little bit of downtime.
Got it. And I think that's a really great segue to getting started to talking about Web3 storage. So can you first help us understand, the problem of centralized storage providers right now, and why haven't more people shifted over to Filecoin, IPFS, or why haven't more people, why hasn't all the companies just onboarded into Filecoin?
So Filecoin, it's working to bring the positives of what centralized storage providers have been able to do, have been able to innovate on, while also mitigating the downsides. So with Filecoin, you're still renting out someone else's hard drive, just like you'd be with a centralized storage provider. So you're still able to really outsource your data storage, kind of, that's something no one wants to worry about storage and keeping that up. So that's really nice. But at the same time, Filecoin's a distributed network of physical storage providers. So resiliency ends up being higher. There's way fewer points of failure. And under the hood, centralized storage providers do have a lot of points of failure. And that's why you usually don't see them go down completely. But there are still plenty of single points of failure. There's still a lot of distributed hard drives out there and many copies of data stored underneath the hood. But by relying on a bunch of independent kind of storage provider businesses, you get a lot more resiliency. The other side of things is in the cryptography of Filecoin and what makes it very Web3. So users usually need to trust vendors to not lose their data, to keep connected, that sort of thing. There's these at $1 trillion market cap companies who provide decentralized cloud storage solutions, and we all trust them because we're paying them a lot of money. Of course, we trust them. They give us an SLA. Why would I trust this random Filecoin storage node? Well, there's cryptographic proofs and also cryptoeconomic incentives to ensure that trust isn't actually necessary. So we love to use this word trustless in the Web3 space, verify, not trust. And that's what ends up happening with Filecoin. These storage providers actually have to periodically generate proofs, these novel cryptographic proofs that actually prove that they are physically storing your data for you. And there's incentives economically, making sure that they're strongly incentivized not to lose your data and continue submitting these proofs. So what you end up doing is having these physical storage nodes competing against each other in an open market. So there's resiliency there, and then they're also competing head to head. These things like egress being really expensive, you can't get away with it so much anymore because then someone is just going to store with your competitor. So you see this in Filecoin's price for storage, where often it's $0 per gigabyte to store data on Filecoin, or virtually $0. So you see the beauty of kind of the market forces there. And then I guess this is maybe a first order thing leading into the fact that there's no lock-in, and you see competition among these storage providers. But Filecoin operates completely using IPFS. So we talked a little bit about IPFS before, but you're able as a user to reference your data by what it is, not where it is. So there's actually no friction from a user experience standpoint for you to store with multiple storage providers or stop storing with this one and start storing with another, because the way you reference your data doesn't actually change at all. So that friction is so decreased. That's why we call it quote unquote decentralized at all levels, not just at the physical storage layer, but also kind of that data layer as well. So that's what it does well.
Yeah, so I think that is a really great synthesis. So in terms of the cost savings and things like really high cost for egress, those things are basically done away with in a competitive marketplace like Filecoin, where you have potentially infinite number of players just competing for these storage deals. So I think that kind of really illustrates the value proposition from a commercial perspective for Web3 storage. So I'd love to actually use this time to talk about what you guys are building at Web3 storage. How does that help people store data? Why do you need Web3 storage?
Web3 storage came about to try and plug in some of the shortcomings with what you see with Filecoin today, but with keeping in mind that Filecoin is still very much in its early days. Right now, it's 2-ish years after its launch. So relatively speaking, for something that's going to be around for a really, really long time, it's still in its early days. So we wanted to build a product that could plug into its shortcomings while being able to take advantage of the upgrades moving forward. So as far as shortcomings go, I would say there's two main ones. So reading data out of Filecoin storage providers isn't the easiest thing right now. And that's because it wasn't explicitly something designed in its protocol. Filecoin was built to make sure that your data was provably stored. But there's other layers that needed to be on top to make sure that you can get the data out really quickly. The other thing is that there is some friction to make sure that Filecoin storage providers can do the cryptographic stuff on top of your data, generate the proofs. So there's this data preparation step that your average user who just wants to store their data, they shouldn't have to worry about. So Web3 storage came into the picture to solve these shortcomings. So in general, our mission is to make it really easy for users to utilize IPFS to build their applications, and then also tap into the Filecoin network for this cheap and verifiable storage. But from a Filecoin focused perspective, it's to make it easy for users to utilize Filecoin because we do all the direct interactions with the Filecoin network for you. You don't have to go through all that trouble or have that expertise while making it performant to read your stored data. So you store data on the Web3 storage platform. It ends up in Filecoin, and you're still able to actually read it out of the IPFS network quickly enough to build production level use cases on top.
So just to clarify, it seems like when we use storage in crypto using this stack right now, our files are stored at the base layer at IPFS or indexed by IPFS. And then Filecoin is the layer that coordinates the storage providers that help you put these files on IPFS. And then Web3 storage sits a layer above that, which helps users access Filecoin, which in turn access IPFS. Is that kind of the right way to think of the stack?
Yeah, I think that's a really good way of putting it. I think you could also consider Web3 storage virtually at the same layer as IPFS. We prepared your data for you. We do the thing like give you the client libraries and the dashboard and stuff for you to track all your data, make it easy for you to integrate into your application. But we're just speaking IPFS just like Filecoin is underneath the hood.
Got it. And is it possible for developers and projects to just use IPFS alone, or interact with IPFS directly? What is the benefit of doing that versus using Web3 storage?
Yeah, totally. And we actually use IPFS outside of the context of Filecoin as well. It's really important to remember, and IPFS I think often gets misexplained, and it sounds like you have a good sense of it. But I would say that a lot of people will use phrases like, "Oh, I uploaded my data to IPFS," which is a useful way of framing things when you just want to tell someone, "Hey, my data is now available on IPFS." But it's a little bit misleading because IPFS doesn't make statements about where the data is physically stored. So you can run IPFS on your laptop. You can run it in a cloud server somewhere with a centralized cloud provider, and you can store it on Filecoin, which speaks IPFS natively. So actually, when I talked about Web3 storage overcoming some of the read performance shortcomings that Filecoin has today and is actively working on addressing, part of that is instrumenting IPFS nodes on our own infrastructure that kind of serves as a kind of redundant layer for the express purpose of you being able to read it quickly yourself. So we do use centralized storage providers to store your data today, just because our primary focus is to make sure that your data is available quickly enough and reliably enough for you to build a actual application on top of it, and with an eye for scalability and that sort of thing. But as Filecoin continues to get better and better, we can stop storing those copies on expensive centralized storage, expensive egress, and just rely on the Filecoin network completely. So, from a user's perspective, we want a world where you don't actually have to worry about any of this, and you only see the nice surprises. Oh, all of a sudden, it's virtually free to store my data on Web3 storage. And underneath the hood, that's because we'll be only storing your data on Filecoin. But there's a progressive decentralization that that's kind of the approach that we're taking here, where the North Star is always meet our users' needs, but with an eye to the future about what's possible.
And I'd love to put it into concrete terms for our listeners as well, because as of late last year, I think the end of last year, Web3 storage already facilitated approximately 479 TIB or 66,000 gigabytes worth of data. So can you share some examples of what are some of the types of projects or founders that are using Web3 storage? What does this 66,000 gigabytes consist of?
Yeah, and Filecoin, the network as a whole, in terms of actual capacity on there, is in the dozens of petabytes. So actually, we're at this point, I think between Web3 Storage and our sister project NFT.Storage, just under a petabyte, or just under a sorry, there's hundreds of petabytes. We can look up the numbers later. I'm not sure about what the the exact numbers are, but that all is to say, the actual data volume that we're shipping isn't all that big compared to the Filecoin network, which is one reason why it's so cheap for us to utilize Filecoin. At the same time, what the data we're storing is super, super valuable. On Web3 Storage itself, you can see a number of projects building decentralized versions of solutions to common problems. You have like the Fileverse team, which is doing peer-to-peer file sharing, the Glitter protocol, archiving public Web3 data, Tatum and Morales for developer tools. You have a lot of these cool, what we call compute over data projects, working with the IPFS Bacalhau team, like LabDAO. They're taking places where we have pretty good Web2 application solving problems, but we can do better in building the Web3 versions of them. In particular, there's a really exciting use case and user that I wanted to highlight because it's not actually someone who's trying to be Web3 for the sake of Web3. They took like a actual pain point that people in the wild had and found that the Web3 solution is the best solution. So there's this gaming studio called 3S Gaming Studio. And they built a plugin for Unreal Engine that makes it easy to make your assets for your video game available over IPFS. And you can use any IPFS provider, even your own node, but the default host is Web3 Storage. And the pain point they're solving for is that the install size of video games is just getting bigger and bigger, especially with Unreal. And that's actually one of the top problems gaming developers have expressed with Unreal. So for instance, the Fortnite PC install is like 17 gigs, which I guess in the grand history of all video games, not that big. But when you think about things like, hey, how do I make this install work on mobile or something like that? It's really, not tenable, and you have to degrade the experience in certain ways. So Unreal comes with a way to optimize what assets are installed and what gets downloaded on the fly. So for instance, you entered a new map and you're downloading those packets of data as you explore a new area, or you just entered the skin store and it's loading all like the user generated skins and content and whatever. So it is possible, but apparently really, really difficult for you to actually do this optimization yourself. And you're an indie game developer. That's not something you have time for. So IPFS is exactly the layer of abstraction you kind of need to make this work easily because all the data is content addressed. So you can optimize that experience for developers really easily with an add-on to Unity, and they can just do this optimization without having to touch any of the under the hood arrangements and things like that. They can kind of just tell you which assets they want when and which you want over the network versus installed, and then that optimization gets a lot easier for game developers. And then real quick, we have a sister project, like I mentioned, NFT.Storage, built on the same platform as Web3 Storage. This is probably the thing that more people are aware of, where some of the biggest NFT marketplaces and minting services use NFT.Storage to store their off-chain NFT data. Magic Eden, Rarible, OpenSea, NFT Port. Recently, even Metaplex Studios' new minting tools is on NFT.Storage.
Yeah, and we'll definitely touch on NFT storage in a bit as well, but I'm really excited about the example you brought up about the gaming studio that's using this, because my assumption was that most of the projects, a lot of the people who will be looking into Web3 storage or Filecoin are already kind of red-pilled on crypto. They already want to build a decentralized consumer application, but this is the first time I've heard of a major use case for someone who's going around searching for a solution for an existing commercial problem and then decided that Web3 is actually the most commercially viable solution to this. So I'm actually curious, just off the top of your head, are there other similar use cases that you think could apply here that is not just completely crypto native?
Yeah, I think generative AI and IPFS are a match made in heaven. And when I mentioned the compute over data projects that are building on top, I'd say that a lot of them are looking at IPFS because of what it brings to the table, just directly competitively. I studied like math and most of my internships before like going into the real world were like data science internships and things like that. So, I did compute over data, use things like Jupyter notebooks and things like that. And it is so crazy underneath the hood how everything is location addressed instead of content addressed, where you want to run a workload again and again and again. It's really, really, it just makes sense for that to be an IPFS because IPFS, everything is linked in a hash addressed way. Without getting too much into the details, you can have proof that a workload that you ran actually ran verifiably. You can send those workloads around just using the hash, the address, content address of the data, not having to ask folks to rerun it, all that sort of stuff. And where this gets really, really nice is potentially in generative AI, where each person running their own model of something, we're going to run really quickly into problems with what's real and what's fake, and verifiability. Cryptographic verifiability is going to be really, really powerful to helping fight it. It's probably not going to be the only solution there, but folks at Starling Lab. Actually, I don't know if it's Starling itself or the same folks behind Starling who are working on this, but looking at ways to make sure that you're able to verify whether media content and things like that was doctored or not. The whole world of IPFS is something that can make this a lot easier.
Wow, and is this something that you can do on IPFS today already? Or are you talking about expanding the use case of IPFS to include like generative AI?
It's more like an add-on, I would say. Like you're not running your generative AI necessarily like quote unquote on IPFS, but IPFS allows you to have a footprint of all the models that you're running that is completely cryptographically verifiable. So it has efficiency implications. For instance, like if you have a notebook or like some sort of workload that you have to run over and over again normally, you can cache it a lot more easily because you can just use the content address for it. But the generative AI piece makes this a lot more relevant because now you need proof that you were actually the person who ran this model, maybe, or this model actually ran in this way to generate this output. All that IPFS inherently gives for you. And, like scientists out there aren't worried about, like their number one worry isn't IPFS itself, but we have folks in the ecosystem building the tools where they don't have to worry about it. It's just something that's there for them and they can take advantage of kind of with IPFS doing the heavy lifting underneath the hood.
Yeah, and before we move on to the other use case, which is massive for you guys, which is the NFT storage part, I'd love to touch on the two other products that you guys have built as well, which is called Web3Name and also Web3Link. So can you explain to us, what those are and how does that fit into this broader picture that you mentioned?
Those are both solutions that allow IPFS and Filecoin to have feature parity in things that are important to users and developers, but maybe are things that IPFS does worse than the Web 2 versions today. So we spent a lot of time talking about what's better. Of course, there's going to be trade-offs there, but we have other verifiable protocols to kind of plug those gaps. So W3Name, it's a hosted what's called IPNS solution. So the NS in IPNS stands for naming system. So what it allows you to do, IPNS, is bring dynamic updatable names to IPFS. So IPFS, the reference is tied to the data itself. So let's say that data mutates, you get a completely new, by definition, like uncorrelatable hash content address of that data. So in real life use cases, that can actually be tricky because people are dynamically changing data all the time, but you don't necessarily have a way to tell them all the time what the updates are. So what IPNS does is give a static, not changing name to that you're able to update. So you can think of it as a pointer. As the thing that you're referencing changes, you can update the pointer to point to the latest thing. And you do this actually using cryptographic signatures, so it's verifiable that the entity who has permission to actually update it was the actual entity who was doing the updating. You can't really spoof it without getting access to their private keys or whatever. Well, the main shortcoming of IPNS is that it just doesn't have guarantees around speed and stuff. It's something that's pretty common with peer-to-peer protocols in general. So what we did was created a hosted IPNS solution where we're kind of the you have to trust us, but we will tell you what the latest update to an IPNS name is, which for performance reasons, going back to our main goal being providing the performance and reliability folks need, is good, but it's bad that people have to trust us. We're like that centralized provider telling you, what the name is. And we've kind of found that IPNS inherently as a protocol, you can't really get around this. So we're actually looking to build a improved naming protocol in the future. And then W3Link, really quickly, it's a IPFS HTTP gateway. Not everyone out there has an IPFS node, so for them to be able to take advantage of getting data off the IPFS network, there's these things called HTTP gateways where it's a HTTP URL. You put the IPFS content address in the URL's path, and you can get the data off the IPFS network that you're looking for. Because gateways have to search the whole network usually for data, it's not always fast to get it out. I think anyone in the NFT space kind of knows what I'm talking about, where sometimes it's slow, sometimes you get timeouts to get things out of an IPFS HTTP gateway. So what we do is run our own gateway that's optimized to fetch content quickly that we have. If we have the data, we know where it is. Why can't we take advantage of that? And that's actually, I'm going to say, kind of actually a crazy innovation in the IPFS space, where people were very decentralized first, decentralized top to down, and they didn't want, even if they had those hints of where it could be sitting, didn't want to take advantage of that. But for just to provide the performance that our users expect, you should be able to get your data out quickly if you stored it with the same provider. We went ahead and did that, and as a result, a lot of people started using that gateway that we provide.
And that's the perfect segue, because you mentioned NFT projects and NFT developers will be very familiar with this pain point just discussed. So you mentioned this sister project called NFT.Storage. So why don't we start with, what was the genesis for this idea? Like, what was the insight that led you guys to say that, hey, we need to start this thing because people are asking for this?
People were really bullish on NFTs because of the thing that they did differently. They were this public data set that no one entity controlled. And you could prove that you owned an actual digital asset. And if you were someone who was looking to take advantage of all this data, you didn't need a moat of private user data for you to be able to build like a marketplace or a wallet or something like that. All the blockchain data around NFTs was public by definition. At the same time, because storing things directly on a blockchain is really expensive, most NFTs have the asset associated with the NFT stored off-chain. So like arts and videos, those are a lot of ones and zeros. To store them on the Ethereum chain probably costs you thousands of dollars in gas. So you store that data off-chain, and the on-chain component of the NFT has a pointer to the off-chain piece. So actually, people were really good about adopting IPFS to solve this problem, because this is like a match made in heaven for IPFS. IPFS content addresses, hash of the data, so you can prove that you have a Pikachu NFT, and someone tries to argue with you, your NFT is not about Pikachu, and you grab the Pikachu image and you can mathematically prove that it corresponds to the content address of the NFT. No one could argue with you, and this was Web3. This was the thing. And you could extend these on-chain guarantees around cryptographic guarantees to off-chain data. But IPFS alone didn't really solve the problem completely around off-chain data, because IPFS only helps with how the data is referenced, not how it's stored. So again, talking about these kind of two layers, how you reference the data and you store the data, IPFS doesn't make statements about the latter. So you saw these cases where a artist would install an IPFS node on their laptop, host the image there and get the content address, make the NFT with it, sell it, and then they close their laptop, throw it in the dumpster or whatever. And if the new NFT owner didn't grab the data before that happened off the IPFS network and started to host it somewhere themselves, it's gone. So you get into this. It's very similar to the economic problem around tragedy of the commons. It's for the whole ecosystem of NFTs to be able to utilize this public good, you needed something that individuals weren't necessarily incentivized to do. So NFT storage comes in to actually store all off-chain NFT data as a public good. So you can kind of think of it as an internet archive of NFTs. So we know the on-chain component of an NFT is safe. Many nodes out there in a blockchain storing the same ledger. But our goal is to take advantage of cheap and verifiable Filecoin storage and smart contracts. And now we have the FVM to do that, to make a perpetual repository of off-chain NFT data that no one entity can eventually control. So what that means in practice is today, anyone can store NFT data for free on NFT storage. And we're also going to start kicking off as we are able to increasingly take advantage of the cheap Filecoin storage piece to actually scrape all the blockchains out there for their NFT data and what off-chain data they're referencing, and archive the data that we can off of that as well.
And going back to that example of the guy who creates an NFT, hosts it on their own laptop and then, sells it and then, destroys the laptop, for instance. When you say it's gone, what is gone with the NFT? Is it the image for the NFT that's hosted off chain, or like what aspect of the NFT is gone?
Yeah, it really depends on the NFT and the standard you're using, but most NFTs, the vast majority of NFTs, have both the metadata and the assets that make that NFT, really meaningful in, culture of human society. All that is stored off chain. So you can't, not even the metadata is stored on chain. The metadata is stored off chain too. So when you go to the listing on NFT marketplace, you can't see very much about it. Usually marketplaces cache their own copy of some of the data at least, but if they haven't gotten to it, then it'll be blank. And if they're not hosting that same data on IPFS themselves, then once you buy the NFT, your wallet's going to have a hard time grabbing it and stuff like that.
Got it. And I noticed that in the rise of NFTs, a year, 2 years ago, that was one of the major drivers for Arweave, which is this project that's offering like permanent file storage. So I'm curious, like, did you guys look into Arweave as well? And how did you decide to go with Filecoin and IPFS instead?
Yeah, and for full transparency, so I'm the CEO of Dag House, which runs Web3 and NFT storage, but I'm also product manager of Protocol Labs, which we're the creators of Filecoin. So you can take that how you will as some form of bias. But I've thought about this a lot. I've talked to a lot of NFT artists, people building on the ecosystem at conferences and things like that, and we always get this question. So definitely looked at Arweave, and I think Filecoin's really cool. But what attracted me to join Protocol Labs in the first place was IPFS actually. And I was really curious why Arweave doesn't use IPFS, because again, Arweave's about where the data physically sits, but they could have totally used IPFS to actually address their data, and they made an explicit decision not to. So I was really curious about that. So anyway, digging into things, Arweave has a novel crypto economic model, and it forges new ground. And that could be a good thing or a bad thing, right? It could be innovation or it can be something unproven. To me, it's TBD whether the crypto economics actually work out. The Arweave network aims to fund all data stored with Arweave, what they call "quote unquote" forever. So first of all, it's like nothing's actually forever, but you dive into how can you make that claim, and they have an endowment that's mostly fixed. There's small contributions to the endowment over time from fees that the network takes. And out of the endowment, you pay nodes storing data, and you pay those nodes proportionate to the amount of the total corpus of data on the Arweave network. So you're basically trying to get people to store as much of the data that users have stored with Arweave as possible to try and get as much resiliency and redundancy as possible, which is a nice idea. But something about that feels a little bit off to me because first, the network's operating probabilistically. If no one picks up the data initially, or the right subset of nodes who are hosting all the copies of a given piece of data drop out of the network all at once, you end up losing the data. And actually, there's a decent number of Web3 storage users. When we asked them why you started using Web3 storage, they mentioned, hey, we started using Arweave at first because this promise sounded really nice. It was nice that they were incentivizing as many nodes as possible to store our data, but we were actually losing data in practice. And I more or less just chalk it up to the fact that it is somewhat probabilistic. So, like, okay, there's probabilistic elements to like SLAs and uptime. You have 99.99% uptime. So that is maybe something that you're willing to take as a user. It does kind of contradict the quote unquote forever piece quite a bit, though. The other piece that I think is a little bit harder to swallow is how when you pay all the nodes to try and store all the data possible, you actually have a cost curve as this storage supply moving in kind of the opposite direction you'd want to get to a nice economic equilibrium. You have a fixed endowment, but that endowment gets stretched thinner and thinner the more nodes and the more storage enters the network. So intuitively, that kind of doesn't feel scalable. You want, as more nodes enter the network, the storage price to go down because they're all competing against each other. So yeah, I guess that was kind of what didn't really make sense to me with Arweave. And then on the other hand, with Filecoin, these economic incentives and cryptographic proofs correspond to individual copies of your data stored on the network. So you know that this node out there or these 5 nodes are all storing your data for you, and you have the proof of that. There's no like probabilistic element there, and they're all competing against each other, so they're all actually driving kind of like the cost down there. You can actually use smart contracts as a layer on top of this network because it's all cryptographically provable to create something very much Arweave-like. And I know a lot of people in the Filecoin ecosystem thinking about this, and some teams actively trying to build it. So you can put funds in a smart contract, very parallel to an Arweave endowment, and you can write in a smart contract, hey, I want at least n copies of this list of content address data at all times. And if it ever falls beneath that number, the smart contract springs into action, pulls whatever they need from the endowment to spin up some new storage copies and top it back up to that number. So you actually can create something like this perpetual storage machine in a completely decentralized way, but in a way that's transparent, where you know who's storing your data at all times, how much it's costing you, and that sort of thing.
I think that's, again, really, really great segue, because you can do that with smart contracts on Filecoin, and Filecoin just launched smart contracts. And I think it's important to first make the context here clear, is that everything you guys done so far with Web3 storage and NFT storage is done without the expressivity of FVM, which allows people to write these smart contracts on Filecoin. So I expect that with FVM, you guys can do a lot more stuff right now. So what are you personally most excited for in terms of being able to use FVM in the context of Web3 storage or NFT storage?
Yeah, I'd say with Web3 storage, it applies a little less directly to what we're building, although because we're a pretty easy on-ramp to get your data into Filecoin, I'd expect a lot of our users to be building stuff with FVM. So I'm excited about that piece. NFT storage, though, definitely there's a lot of overlap with what it can do with the FVM. So this perpetual storage vision that folks are aiming to build, that's something NFT storage can totally take advantage of. The goal as this Internet Archive public good of off-chain NFT data is to completely decentralize itself. It wants to be a DAO. That DAO can be in an FVM smart contract. It wants to have an endowment and an FVM smart contract. And it wants this perpetual storage enforced by smart contracts for the data that we're seeing as actual NFT data, and storing really, really cheap using the Filecoin network. I would say in terms of tangible pain point that this is solving, we talked to these NFT marketplaces, and independently, they're all doing this chain scraping effort. It makes sense. Without being able to display an NFT's image or get the metadata out, they can't facilitate a sale. That's something that directly impacts the revenue. So it's this burning business problem for them to solve, and no one else is actively necessarily solving it for them. They take matters into their own hands, but it's so wasteful. They're all doing it. They're all having trouble with it. And rather than separately try to scrape all the chains themselves, this is exactly the kind of effort that we can put in a DAO instrument using smart contracts, and from an economic perspective, decrease the individual cost of each of them doing this effort, because one person or one entity is doing it for them, and it's a classic public economic surplus there.
Got it. That makes a lot of sense. And I know we've covered a lot of ground in this episode. So if for people who've made it to the end of the episode, if there's one type of founder or one type of project that you love for them to reach out to you to use Web3 storage or NFT storage, what type of founder or what type of project would that be?
Yeah, I would say folks that are interested in this world of self-sovereign identity, there's a lot of really, really cool identity primitives and user-facing identity projects and products coming out. And we're actually working on a new version of our upload API. It's called W3Up. It's in beta right now. Next week, we'll have kind of a release candidate for it to be like very just usable end to end, and in the next quarter to migrate NFT storage and Web3 storage over to using it. But what it does is it not only takes advantage of the IPFS decentralized protocol where you're verifiably referencing data, but this thing called UCAN, which the Fission team they kind of pioneered, which it brings a very similar verifiability to API interactions and user identity. So you're actually able to we're going to have all our users have key pair based identity where they can, for instance, delegate permissions to upload to their account to someone else, or delegate permissions to read the list of uploads out of their account to someone else. So an example of the former would be, you're a NFT minting service. Right now, to upload to any service like NFT storage, you need to facilitate the data being uploaded to your server and then upload it to our servers, versus in the future, very soon future, you're going to be able to delegate permission to your user to directly upload to NFT storage on your behalf and do this signing the token with your key pair. So everyone's going to have their own identity. The more interesting version of this is, hey, now you can have users with their own identity, and they're plugging that identity into an app that some developer wrote for them, but that developer doesn't have to run a backend themselves. They don't have to keep data on any servers. It's purely a transaction between their user and Web3 storage, or and then the underlying storage providers to store that data. And because it's key pair based identity, we're not really thinking necessarily about the ways that we're going to plug into the key pair based identity systems that exist, but all of them are interoperable with the UCAN world. So someone can sign in with their MetaMask wallet or their Disco backpack, or even in the Web2 world, Apple Passkey. That's a primitive that's key pair based. That's really exciting to me, because you start to solve a big pain point for developers themselves, having to run all this infrastructure just to have an app go up, going from on-prem servers to cloud, and now it's cloudless. So that's really cool. And then you are able to have users make their own choices for their data and protect their data, give consent to who they need to access that data, which we see it in the news all the time with a lot of there's a data leak every day. Oh, so and so did this with your private data. This is a real pain point that folks are facing.
Yeah, so you heard it first. You heard it here first. If you're building an ID solution on Web3, I know there are many of you out there. I have a personal few friends who are already working on different types of ID solutions. Filecoin, definitely reach out to them. So on that note, David, what are the best ways for people to reach you?
Yeah, so I stay off social media myself, although I did make a Blue Sky account. So I think for us, the best way to reach us is to pop into the Web3Storage Discord channel on the IPFS Discord. You can send an email to support@Web3Storage, or you can ping me, I guess, at dchoi on Blue Sky. So yeah, excited to hear from all of you out there.
Perfect. Well, thank you so much for coming on the show, David. This has been fun.
Yeah, thanks for having me. This is great.
All right, that's it for this week's episode of the Blockcrunch podcast. So thank you so much for tuning in. If you enjoyed this episode, please make sure to subscribe on your favorite apps. And in case you didn't know, this interview is also available as a video on YouTube. And if you tag the Blockcrunch on Twitter this week and tell us what you liked about this episode, I'll be sure to respond to you as well. Now, if you'd like to go even deeper, we have a VIP tier where every week or so, we write an in-depth research brief or investment memo on a project. And we'll have exclusive AMAs with myself where I answer all your questions as well. Now, we already have analysts from some of the top funds and companies in crypto as subscribers. So if you're serious about getting an edge in crypto, head on over to theblockcrunch.com/VIP to learn more. And once again, thanks for supporting the show, and I'll see you next week.